Okay, so make sure you are on the side that says empirical formula. So basically with empirical formula, this is something that we call the simplified formula. So just go ahead and change that title up there. Don't change it, sorry. You should just write it above it. Simplified formula. All right, so what I mean by a simplified formula is the idea that the subscripts down below are going to be in their simplest form, all right? So they cannot be reduced any further. A place where you saw that already was when we had something like, say, lead for oxide, and so you had Pb2O4 like that, and you basically looked at that and you knew, oh, we got to change that to be a 1 and this one to be a 2, so it was lead PbO2. So we did that with ionic things, right? But we didn't do it with our covalent things. We just kind of left our formula alone because I told you guys, like, oh, those don't change, things like that. Now what we're going to get to see is that we can take the percent compositions of our different formulas, and that gives us this thing called an empirical formula, which is something that we are taking those molecular compounds now and simplifying those down. So the first thing that we're going to handle is the idea that if you're given a compound and asked to give the empirical formula, you're bringing it down to the smallest whole number mole ratio. Okay? So, for example, they gave us B2H6, and they said the empirical formula simplifies down to be BH3, right? And you get that by dividing each of those elements, their subscripts, by the number 2, right? So we got that. So that part's not overly challenging in my opinion. So go ahead and take a look at the right-hand side of your paper, okay? I want you to try it on number 1 and number 4. So number 1 and number 4. You're trying to decide what they can be divided by and what it simplifies down to. Okay? So we have C6H12. So 6 and 12 can both be divided by the number 6. Right. So that would make this empirical formula be what? CH2. CH2, okay? All right, and then right below that, you have C2H6O4, right? So what can we divide all of those by? What? 2. So when we do that, our answer ends up being what? CH3O2. Good. Okay? So those are the empirical formulas of the original, which we call the molecular formula. So we'll talk about that a little bit more towards the end of class. You might run into a case like you have on number 2, right here, where it says iron, this is iron 3 oxide, right? But we have a 2 and a 3. Can this one be reduced any further?
No.
No. So this one we would, if I'm asking for the empirical formula, you would just say the same exact thing, right? So this is the empirical formula. I can't make my E any better, sorry. All right, so that hopefully is not overly challenging yet, okay? All right. So now what we're seeing on, back to our notes, okay, it says if we are given a bunch of percent compositions, we can then figure out our empirical formulas, all right? So percent composition is something you've been working with, and what we've gotten to see up to this point is that no matter what, percent composition will remain true, right? Doesn't matter how big your sample size is. So that's why we rely on it so much. So take a look at your green page real quick because I wanted to point out where you have some information on here. So you have your mole conversions here that we've been working on. We're going to be using this one today a lot. But empirical formula is listed right here. So for empirical formula, these are the steps that we're going to end up writing down. So I wanted to make sure that you knew you had this. And then you see this little exception thing. And so when we get to the question that has the exception, that's going to be what we refer to. Okay? So the steps to figure out an empirical formula